So I'll talk a little bit about adventures using large public data sets and the pros and also the cons. So my outline is I'll talk a little bit about what big data is, why you would bother thinking about big data, where to find them, and challenges, pitfalls, and opportunities. So what is big data? There's a really nice paper that's now a few years old on what actually is large data. I don't know any of you who haven't read this want to hazard a guess. So the winner in terms of data input rate was this square kilometer array in Australia. Any guesses? And anyone want to volunteer to be their IT manager? No. You're going to be wrong. They're going to move up to 750 terabytes per second. It just hurts just looking at it. So big data standards vary a lot, but I think we've made a lot of progress, and I'll tell you a little bit why you might bother and why it might help you. Well, firstly, one thing that most of us here will have thought, myself included, is, well, if I found an effect in a small sample, then there must be something there. There's a terrifying paper by Andrew Gelman that I implore you all to read, which has the scariest plot in all of psychology, which essentially means if you have 6% power, which is not nearly as rare as it should be, and you find a significant effect, so you thought, well, I found it even there, you have a 20% chance of concluding an effect in the wrong direction. And any effect you do find is at least 9 times overestimated. So you see this in very small training studies, like, well, the effect size Cohen's D of 9 or 24 or something ludicrous. That's just because you use a smart sample. And just to kind of reiterate this point, take into account Camilla's caveats about kind of mixture modeling of these data sets, 6% power is not rare. So a lot of our effects are in the wrong direction. And all the ones we know that we now base our power calculations on are overestimated by almost an order of magnitude. So that's why you should care. So you should bother with this because many of these data sets that I'll discuss are free or almost free, and more statistical power is almost always better. So that's not necessarily true if you're doing, say, medical intervention. You don't always have to do it on 1 million people. But other than that, there's no such thing as an overpowered study. So this is biobank data where we looked at age-related decline in fluid intelligence, and the base factor for this association is quite large. It's reproducible because you can have the code and there is a public data set out there, but also generalizable and replicable. So one of the things we did here, so we have a CALM cohort here, which is kids recruited by a particular mechanism. And one of the things we wanted to know for sure, regardless of what our conclusion was is this idiosyncratic to our data or not? So we essentially had a particular structural equation model we were interested in. This work's led by Delia Furman. And then we went out and looked at the NKI-Rockland sample to fit exactly the same model and compare the similarities and differences between the two cohorts. So then we could say something about, does our conclusion hold across these two data sets? And if so, which ones? And if so, which don't? It may also inspire new questions. There's a really nice paper from last year or 2 years ago where they essentially looked at these G by E interactions of socioeconomic status across countries. So suddenly you might start to ask questions, well, do I think this type of effect will be the same across countries, or would it vary as a function of, say, economic disparity between people or the social safety net and those? So questions you might not even have thought about if you were testing 24 undergraduate psychology students, but actually you should or could be quite interested in. And you can develop, apply, and test new models to real data. So what's the procedure? You find a suitable data set, you apply, you wait some more, then a miracle occurs, and then you get some data. So what are some of the open data types? Well, some databases that I think are worth highlighting. The biobank is one of the most famous cases. They have a sample size of 500,000 people, and they have data on everything. And it works remarkably well. So they have genetics, they have behavior, demographics. They basically linked up a lot of existing data on these people from birth way to anything, including a set of cognitive batteries. It's not free. It costs £2,000 to apply for the data, but you're paying for very competent people helping you on short notice. So the ABCD is a new cohort of children, 10,000 children being scanned with a cognitive battery, mental health questions, neural data, and they're going to follow them up over the next decade. The Human Connectome Project, Imogen, the Philadelphia Neuro something, and the NKI-Rockland, they're just kind of a subset. But even if you just took those and you were interested in, say, working memory, all of these have a proxy for working memory. So spending maybe £2,000 or £3,000, you would have yourself a lot of data. And there are many others. Some have more drawbacks than others. For instance, I think it's still the case that ADNI, all the people who made the data are co-authors on your paper, which is a way to get a large publication list, I suppose. But there are other, maybe more kind of modern ways. You could simply reach out online. If you kind of ask on Twitter, does anybody know of large public data sets involving X, you will get a surprising number of useful responses. And as one of the first speakers mentioned, Google Data is possibly a way to link all of these things in a way we can find them. So can we integrate these with other open science practices? Well, data sharing, that box is ticked. You can still pre-register, so we've been pre-registering our public analyses because essentially we still have a timestamped file so we can show the world when we pre-registered our analyses, and we can also show the world, if interested, when we actually got access to the data. So you can pre-register in many of the same ways. Now, not if you already have the data necessarily. And there's a template on the Open Science Framework on pre-registering secondary data analysis. So essentially more tailored to the idiosyncrasies of pre-registering something that already exists. It's also reproducible, so one of the things we did in our biobank analysis that I will return to shortly is essentially we shared all the code and then pointed people to the biobank database. So if they applied for the data, downloaded it, and ran our code, they should get the same answers as we did in our paper. So it's still reproducible, although it might require one extra step. So how about large public data sets in practice? I'll give you some good, bad, and the ugly. So the good, this is a data set that we were analyzing the other day. It's called Open Psychometrics, and essentially raw data for personality tests and kind of some mental health tests. It's here, and the font is small, but these kind of casual lines here that look a bit retro are 50,000 people, 50,000 people, 10,000 people on narcissism, personality, mental health, all kinds of questionnaires. They're all online databases, and they're all reproducible or reusable for free without any paperwork. So they're freely downloadable. We looked at stress, anxiety, and depression, and it took 5 seconds. You download a zip file, and you open it, and there's all your data. So you might think this is likely to be terrible data because it's an online data set, but actually we fit this relatively complex model of stress, anxiety, and depression, and it fit incredibly well. You would not distinguish it from kind of your homemade, tailored data set. And we had a bunch of personality predictors of these dimensions of stress, anxiety, and depression, and we're able to explain about 50% of the variance in individual differences. So these data look as nice as you might hope they do. And we now use it. So essentially we got reviews on this paper, and they say, well, you need to have another illustration of this technique. So we used this data set, and now it was accepted because it was a relatively common question people might have. So big data isn't just kind of, or open data sets aren't only appearing out of kind of a mandate you must share data, but also because we're increasingly leveraging technical tools. And this is a project I quite like. It's called the Math Garden from my former colleagues in the Netherlands. And essentially it's a game where you can win points by making sums and doing language games. And you incentivize kids by giving them fake points, and that's all you need to do because ultimately we're all rats. They participate, so they pay £1 per year or something like that. So those 3 ingredients, and they are currently up to 1 billion responses. So a good proportion of Dutch kids are doing this, and they're doing this at 6 a.m. because they can win points and their plans grow and they win prizes. And it's accessible through just a signed form, which essentially said, I'll not try to identify these kids. And the reason this is great is not because it's a billion responses, because at some point you don't necessarily need your p-value to be much smaller, whatever your statistical inference technique is, but because you can think of entirely different questions. So you can see one child here learn the sum 4 times 6 across a period of 2 years. So here they didn't really know, they guessed 40, 30, and here you almost hear the frontal cortex creaking, but it took about 20 seconds, and kind of more frontal cortex, and then 24, and then it just kind of crystallizes. You see it almost happen in front of your eyes. So the questions you could then ask, is this idiosyncratic about this sum, or are they also clicking in multiple domains? Are they figuring something more general out? Those types of questions don't even really make sense in most paradigms. This is data for, I think, 200,000 children. The type of things you then see in this type of data is that they all get a little bit more stupid over the summer holiday, which is, I think, a good way to spend a summer holiday. In fact, the data is so precise that you need the eye of faith a little bit, but if you look here, and this is pertinent to all of you, they even get a little bit more super over the Christmas holiday. Now that's not a quantitative difference. You simply could not even think about this question with 1,000, 100, 500 kids. Final good example, the SHARE data set is a survey of health, aging, and retirement in Europe. This is free and easily available. You sign a PDF, send it, they give you approval. And hey presto, you have 110,000 people in about an hour. So we looked for a particular project that's some cognitive health measure, a simple immediate recall, and some mental health on a commonly used depression scale, They have 6 waves. I'm plotting 4 here. 27 countries, so you could start to see whether these things are linked in different ways across countries. And we fit a series of growth models, and if you think, well, this data too is likely to be noisy, we fitted the correlation between the slope, so the within subject decline in memory as they age, and the within subject increase in depressive symptoms, which looked like that. So this is about as nice a data as you could look. Now that doesn't mean they have everything you might want, but if they happen to, then you get a lot of benefits for very little cost. So that's the infomercial part. How about the bad? So we looked at the biobank because we're very interested in age-related decline in fluid intelligence in our lab. So we did the data access and acquisition, everything worked smoothly. We pre-registered our hypothesis that these and these neural tracts and neural regions would explain individual differences in decline. The data looked very nice, so these are 20,000 hippocampi. Now it's worth, very few people in history have seen 20,000 hippocampi in a single plot. I mean, it's quite unique. Like we should not be blasé about the fact that we have access to these kind of data. So everything was great. We're very excited about getting our data. And then we got our cognitive data, which they must have cobbled together on a Friday afternoon. It was not really 3 waves. There were only 1,000 people out of these 160,000 who actually had 3 waves. It was not fluid reasoning. That's one of the questions there. What's the largest number? Which at best is a dementia screening test. It was self-paced. There were ceiling effects, floor effects, and the items were memorable, which led to there's essentially a mean increase across years, and there was no significant slope variance. Now, I tried to simulate data where essentially there are no individual differences in slopes, and I couldn't. Even when you simulate data in 100,000 people, it's still significant. So this is a bracing experience. On the good side, because so one drawback is that you are at the mercy of the data available. I showed it can be very good, it can be very bad, but there's not much you can do about it generally. But because we pre-registered it and it was all public, we were still able to publish it, if only as a kind of a warning for other people who want to use this task. I should say Biobank have taken this on board and are already collecting a proper fluid intelligence task in a few thousand people right now. So how about the ugly? Well, the drawbacks of open data can be time. So this is a project we're applying for now, where I play a minor role. So our initial request was 21st of September. And we're still kind of months later on the extremely polite following up of where's the data. So occasionally you get a half an email back, so 2 months in. And that's not too bad. So this is data currently Dr. Delia Furman applied for in October 2017. When she was not yet a doctor, we are still waiting on this data set. I should say this is not the fault of the intention of that department, but rather the implementation of the GDPR and one overworked person being responsible for the entire university. But essentially, it's not always the case that you can rely on these things being sufficiently quick for you to use in every project. Effort, well, here we have our Wonder Woman Victoria, who will sign any form relatively quickly. Beyond the CBU, when we needed other things signed, it took us 36 emails, and by us I mean Delia, 10 phone calls, and 3 months to get a single signature. So things can take a while. The requirements, so this particular data set, and I should say that I don't necessarily think this is a bad thing, so this is sensitive data, but it did involve anyone who shared the office needed to sign an NDA. They could not be in the office if the computer was on. The computer had to be air-gapped, like literally not connected to the network or the internet, which makes updating all these kind of fancy, really lovely talks about notebooks. You can't do that with this, because you can't. And we had to enter a password every time we loaded the data. So to summarize, there are many benefits for researchers, including power, replication, precision, widening access, and enriching existing paradigms, and learning and teaching data analysis. But where does all this data come from? Well, here is where you can and should play a role. Some carrots, you can deposit your data in resources like OpenFMRI, where you have to do very little to it, scientific data, and the Journal of Open Psychology data. If you think, why might I bother? Well, after about 8 years after my master's thesis, we finally got around to depositing mental rotation stimuli I'd made. I get far more thank you notes for this than anything else I've ever done. And a few thousand people use it, and especially from all over the world, people who just wouldn't have access. And this is not a particularly remarkable data set. It's about 80 people, reaction time data, and a set of stimuli people can use for free. And people still don't really believe you, so that even though it's in the Journal of Open Psychology data, they still email you, can I really use it? someone proposed a new science award for the Research Parasite Award. So if you're reanalyzing data, and because it's the internet, someone made one. So you can now actually apply for the Research Parasite Award and win a prize. So we've done a little bit of this where Rick and Darren have done a lot of the work. So we have a Campaign data portal where we already have 400 downloads. So we have a managed access because of our ethics where people have to sign kind of essentially a list of requirements, including not actively identifying the data, which of course takes effort, it takes time, and it takes kind of personnel, but I think it's quite heartening, and hopefully in the future will be something we can show funders saying, if you give us money to collect this kind of data, we will make it a useful resource for the whole community. If you do both, if you share data and reuse data, you can apply for the Research Symbiont Award. We're well into various kind of types of species that either parasitic or symbiotic. In terms of sticks, so sticks will be coming, so these are all carrots. For instance, you can't apply for Horizon 2020 ERC funding because now open data is the default. So you now have to make a case why your data will not be shared rather than doing all the extra work and making it public. So to summarize, there's an ocean of data out there. It can be your primary focus, but it can also complement other, say, experimental work. So you might have a particular tailored design, which is exactly the way you want it, but you might want to bolster such a conclusion by grabbing a large publicly available data set and seeing whether the conclusions generalize. The benefits are many. The challenges, I think the cost is generally modest, not that I have £2,000 kind of lying around, but there are ways to fix this, and many of these data sets are fully free. Time and effort are relatively negligible, so even the worst case scenarios where it took a year to get the data, if you collected anything like that data, you would be waiting 5 years or 10 years or even more. The suitability for your particular question varies from low to high. So many of these kind of are focused on individual differences or on the more epidemiological end of things. So of course, not particularly tailored to people with specific experimental designs, but some do exist. So Biobank has a few basic fMRI experimental manipulations. And there's an increasing kind of hybrid form, such as the DPUK, where there is a large database of people. You can then identify people and say, I would like to test these 150 people for this particular paradigm. So that's essentially a hybrid form where you can gain access to large existing cohorts where you already know a lot of things, so you wouldn't have to do that again, and then have either an intervention study or a particular experimental design. So I think ultimately that'll be the best use of our collective funds when we already know a lot of things, such is the case in Biobank, and then we have a particular intervention or implementation that kind of enriches that data set even further. But none of this goes by itself. So I would argue data can, and where possible should, contribute to the ecosystem. You can adapt your ethics forms, which is what we've been doing here in the CBU over the last 2 years to make data sharing the default. And I would argue against deciding which data set is valuable enough. So as soon as these types of tools, such as Michael talked about, become more and more available, it should be easier and easier for people to say, I want all the data of 24-year-old women T1s. So you might say, well, my data isn't worth it, but if 10 people have worthless data, then suddenly it's a few hundred that actually might contribute quite a lot. And on that note, thank you very much.